Hi, everyone, and welcome to the MLOps podcast. I am your host, Dean, and today I have with me Guy, who is a friend since a very, very long time, and also my co founder and partner in crime at DagsHub. He's the CTO of the company, and as you might already know, we are building the platform for machine learning teams to help them collaborate and manage their projects based on open source tools. Guy has over 14 years of experience in programming, data engineering, machine learning, and many more cool things. He's worked on backend and data engineering systems at Glassbox, handling petabyte scale data pipelines while helping build out the machine learning capabilities of the company. And he's pursued graduate studies in machine learning at Tel Aviv University, from which he dropped out to found the company. So he's a proud university dropout as well. Now, this episode is going to be a bit different from what we usually do. It's sort of an experiment, so we'll be talking a bit about what led us to start the company, but also discussing some general ideas and learnings that we've had from speaking with people in the industry about how they deploy models to production. So, with that very long introduction, hi Guy, it's great to have you here officially.
Hi Dean, nice to meet you. Finally,
Yeah, yeah.
from this from
It's
this side
been
of the table.
Exactly. It's been since yesterday since we met in person, so we're doing this from our homes.
Hmm.
Um, but yeah, I mean, this is sort of. I think the first thing we did was a podcast where we were hosted in someone else's sort of gig. So that was the data engineering podcast. I think that was our first experience. And
Hmm.
then we decided to start this on our sort of own, and so now this has been a long time coming, basically.
Yeah,
Uh,
and I've been
yeah,
informed about this yesterday, by the way. So I'm sorry for any nonsense I might say. I come as I am.
yeah,
Um, One correction about my bio, which is important for my mom. I did not drop out. The master's degree is on hold, on indefinite hold. As far as mom is concerned, I am still potentially finishing it. Um,
yeah.
and
I think there
maybe,
was a yeah.
yeah,
No, go ahead.
on another topic, maybe we can take advantage of this unique episode to introduce Dean, which was never done before. He introduces everyone. Um, so, briefly, let's see. The way I always introduce Dean is that he's a man of many talents. He's a designer and developer and makes a lot of very cool graphics and web designs. One of the, let's say, fastest people I know in like diving into a topic that he doesn't know and just performing better than 80% of the people who are already in that topic very fast, um, including development, but also uh, he is Master Ninja, which I don't think he wants to expand on, but martial artist. He's been my friend since age 5, actually, and he has a lot of very cool hobbies, and also both a physicist and machine learning person. So just before DagsHub, he was doing research on quantum optics, right?
Yeah.
Is the way you would put it, and basically knows a lot of stuff. Smart person.
Okay, so you're making me blush. Thank you for that introduction. So yeah, if you didn't know any one of those background details about me, now you do. There's no better person to do the introduction than Guy. But yeah, but let's dive into maybe more on topic things. I think some people maybe that are following our content have heard some of the background story of how we came up with the idea for DagsHub and sort of started this entrepreneurial journey. But the sort of original idea came from mostly from you. So what was the original idea? and what led you to have it, and how has that idea sort of evolved since then?
Hmm. Um, okay, so a bit about. So you did say that right before DagsHub, I was working as a developer in a startup called Glassbox. And what I was doing there is a mix of backend, DevOps, data engineering, and a bit of machine learning. And basically, it was a small startup. I was one of the early developers, so doing a bit of everything. And even before joining DagsHub, like I was working in some unrelated areas, cybersecurity, mobile development. I realized I don't really care about any of those fields. Um, from reading online and a bit from my bachelor's degree, I was realizing that like we're on a very rapidly rising slope of the importance of data and machine learning. So I wanted to work on that. Like I didn't know when I joined Glassbox basically anything about data, but I realized that it doesn't matter. Like I need to get into the field and learn as fast as possible. And it's kind of inevitable that this is going to be the future. No matter which way you look at it, if you're an AI skeptic or an AI optimist, either way, it's one directional. So anyway, I was working at Glassbox, and simultaneously I started a master's degree in Tel Aviv University, as Dean said, where I wanted to do research on deep learning. Um, and basically, there was a year where I was reading all the deep learning papers. I don't remember how many exactly, but I read a very large chunk of them. And I was kind of at the point where, okay, get uh, I get the idea of deep learning. I have research ideas. I have started doing a bit of research projects with other students in the university. All this while being the guy in the company that I was working in that maintains the Git kind of, and the person who always people approach with questions. And I've always been very into developer tooling and DevOps and developer practices. So some people like hate Git and only know it as much as they have to, and I'm not one of these people. I like really connect to it at a conceptual level. So this is all the setup. What happened was that while I was working on the research projects, I noticed myself using anti-patterns um, from when I used to use before I knew what Git was. For example, and a lot of people will say, yeah, I did that too, or I am still doing this too. For example, automatically creating a folder for every experiment that I run, and the name of the folder has like the hyperparameter values in it, so that, and then later building a script that goes over the folders and calculates metrics and retrieves the right version of the model and everything. And all of this, of course, was going on in a Jupyter notebook in the cloud. And of course, there was no versioning or anything. Um, and I caught myself doing this, and I said, "Wait, this is how I used to do things when I didn't know how to work." Probably professional data scientist, which at that point I was not. Like I was an engineer at Glassbox. Um, I was a student researcher at university. I was never like a professional data scientist. So I thought, okay, the professionals probably have their stuff figured out. This was in 2018. So I searched around and asked people and found out that no, like there are some tools, especially for experiment tracking, for running pipelines. But the whole Git like, or I should say GitHub like workflow of I create a branch, I I keep track of my results. I then create a pull request, and I can parallelize my work with other team members and then easily combine the results and compare them. All of that was, for some people, like a big pain that they didn't really know how to solve, and they invented a ton of internal tooling, or else like completely out off their radar, um, which I interpreted to be the same as like when software developers would email each other snippets of code as a means of collaborating in a team. Obviously, we've moved past that point. So I was kind of shocked to discover that such a high-profile field is lagging behind in terms of workflows and tooling. And I said, and I talked to Dean about this, and I said, listen, I don't think this makes sense. Um, like this field is definitely growing. It's going to at some point have a GitHub-like experience, and maybe the clearest proof of what I was seeing is that there is no, or there was no, open source workflow for machine learning at all. Like it just did not exist. There are only uh, one-sided dumps of code basically, and a link to download the trained model, and maybe a link to the data. But what definitely didn't exist is a way for someone to permissionlessly fork a repo, create improvement, and merge it back. And in short, it didn't make sense to me. And after some trials and dilemmas and time and everything, to make a long story short, Dean and I decided to work on making DagsHub to solve that problem. And we had a lot of other things we considered doing, but in the end we said like, okay, what's the one thing that we actually really care about doing and not just we think it's a good business, and that's DagsHub, even though everyone told us basically, no, don't do it. It's a hard business to build. But in the end, that's what we cared about, so that's what we decided to do. And yeah, I think I maybe cut a few corners along the way in learning. Like initially, we had much more, let's say, focused goal of creating visualizations for data versioning, because there was a lot of demand from people using DVC that okay, I can version my data, but I can't see it anywhere unless I clone it locally. So that was the initial thing. But obviously it's evolved since then. We thought about the bigger problem, and I think that covers everything. No?
Yeah, no, I mean that's more or less the way I remember it. I sort of I guess so a few additional anecdotes are that when we got started, we were both living pretty far away from one another. So I was living in Jerusalem, and Guy was living in Haifa. So for those of you that are not familiar with the geography of Israel, that's basically somewhere between an hour and a half and a 2 hour drive from one another. And so the first year, almost the first year of working on DagsHub in garage mode, we would drive to one another every other week and do like basically a 3 day sleepover and then 2 days work from home. This was before COVID, so working from home was not as well figured out as it is today. But one of those times I was staying with Guy, I remember we went out to meet a friend after a day of work. And this was still when we were evaluating different ideas. And we spoke to the person who was Guy's former boss. And
The missing context is it was 3 a.m. We were in a bar in Haifa, and my old boss, the CTO of Glassbox, is basically always awake. So he agreed to talk on the phone with me at 3 a.m. and didn't continue the story.
Yeah. My cat has come here to get attention, so I should probably kick her out in a moment. But anyway, so the point was we spoke with him really late at night about some of the ideas that we were contemplating, and he basically told us, "You guys are nerds. You should work on an idea that is valuable to nerds. That's what you should be doing." And that's, I think, at least for me, that's the moment that I remember as the moment that we were like, okay, we're doing this, and this is going to be the thing we dedicate the next long period of time to solve. And as Guy said, I think it has the combination of being something that we're genuinely interested in, we genuinely care about, and we thought like it could affect our own lives as well as the sort of the lives, the workflows of people that we sort of enjoy spending time with. So I think that's sort of the personal aspect of these things. But I think that one of the interesting points is some of the things that you mentioned in your answer are things that at the time were not yet resolved issues in sort of the world of machine learning and MLOps. I think Jupyter notebooks, like when we got started, it was a very controversial topic, which I feel is a bit less controversial today. It's still maybe somewhat, but like, should you use them in production, and if so, how? Is like a really big topic in machine learning then.
Yeah.
So
In 2019,
yeah,
it was like PlayStation versus Xbox or Android versus iPhone or something. I call it a holy flame war. You know what? So it's a combination of two things. Flame war is when people argue while insulting each other. A holy war is when people argue about things that there is no correct answer either way. It's a matter of kind of taste and belief. And the holy flame war is a combination of both.
yep, definitely felt like that. But I guess like, what other things do you feel sort of have been the biggest changes since we started in machine learning and MLOps, both in the landscape and the way people think about these things?
hmm So, yeah, first of all, there is that thing where maybe to give closure to the people who maybe were not aware that the war existed or how it was resolved, at least as far as we can see.
We
So,
hope we're not reopening it now.
uh, yeah, so to me, it felt like it resolved to the common sense perception, which is notebooks are a good tool. Use them for interactive, running a command, seeing its results, especially important for data science where you experiment with a lot of stuff and you need to visualize it much more than when you write code, like plain code, and there's not like good graphs and stuff to see. So use them, but don't use them as like the one in all uh, tooling and framework for everything you do in machine learning. In the end, uh, your code needs to be, let's say, or I should put it like this: notebooks by themselves are just kind of a text editor. They're fine. It's like working in a terminal that saves the commands you run and saves the results. It's good, but it encourages, just like working in a terminal, bad practices of not writing your code in functions and versioning it and testing it and everything. So it's not that working with notebooks is bad. It's just that it by default encourages bad behavior. You can work around it with notebooks. Maybe the most sane solution is to use notebooks for experimentation and take the code out of the notebooks into a normal, whichever code editor you like, to get all the benefits of normal code editing, like versioning and reusability and everything. As far as I can see, that was the way the war resolved, and I'm happy with that resolution. Each tool has its place, and absolutism is bad in both directions. Um,
Absolutely. Yeah,
so
but what
yeah,
other
other
shifts? So
stuff.
Jupyter Notebooks was, yeah.
So as I mentioned, uh, it felt like in 2018 there was only like a handful of MLOps companies, most of them doing competing versions of experiment tracking mostly, and a bit of like training pipeline, uh, let's say orchestration, or um, when I say orchestration, I mean like I can submit a pipeline and it runs it on some cluster of machines, which I guess it makes sense. Those are like the immediate concerns of every person who wants to run experiments, and that's like the maybe the first thing that happens. Um, but honestly, it was I don't know if I would call it maybe a bit boring because um, there wasn't awareness of professionals yet that MLOps means something more than experiment tracking and how to run pipelines. Now, I think, first of all, obviously, you look at how many MLOps companies existed then versus now, it's like 2 orders of magnitude more, I think. Um, and
I'll add that I think that sort of I don't know if it's a precursor or in parallel to this. Like there, when we got started, there was no notion of MLOps. Like MLOps was not really a term anyone used. Everyone called it like developer tools for machine learning or ML tooling or something like that. But the fact that MLOps is now so ubiquitous and like a term that everyone basically knows or at least has heard of, as I think
mhm,
one change that sort of relates to what you were talking about. But yeah, but that also meant
mhm,
that people could have a sort of a rallying flag. So now there are
yeah,
a lot of MLOps companies, and yeah.
t- to me, I don't really care that much about the word used, but I think it is a bit meaningful in that if you ask me, for example, let's put ML aside, what's the difference between developer tooling and DevOps? Or some people, it really kind of annoys me when some people think, oh, the DevOps person, what they do is SSH into machines and restart them. I'm like, no, you're describing an IT person. That's well and good. That's an important role to have in many places. But DevOps is not that. That's what DevOps is when things don't work. DevOps, when things work, is an entire philosophy, methodology, workflow of how to tighten the feedback loop from developer to production. Or in plain terms, if in the past a developer would email code or something to an IT person who would SSH into a machine, replace the executable, restart the machine, and this whole process would like need to be scheduled months in advance to and have like disaster recovery protocols and everything. No, now you push to the main branch of your repo, and the Kubernetes cluster can sample it every 30 seconds and deploy it without any downtime with automatic rollouts and everything. So that's DevOps with all of the automations along the way. For those interested, came from how Toyota manufactures cars. And MLOps to me it means the same philosophy and not just here is a tool to do something, here is a tool to do something. It's a mindset. And yeah, I think teams naturally have gotten more friction with reality. Obviously, the future is already here uh, all the time, but it's not evenly distributed. So even in 2010, there have been plenty of teams that have already kind of got this friction with reality and have done internal MLOps for things like linear regression and decision trees, which were maybe more popular then. Um, but in the few recent years, the future has become more evenly distributed, or at least the companies that are really in the future, like, I don't know, Tesla, uh, have progressed even further into the future, and we are a few years from catching up with them now. So yeah, not just experiment tracking and pipeline running, but deployment and testing, and feedback loops, like monitoring from production back into training data, um, advanced labeling techniques, lots of stuff. Fairness,
The world
explainability.
is, yeah, the world is in a very different place. I do agree that I'm sort of trying to think about this about whether or not we closed the gap. Like there is a more evenly distributed future, as you say today, or whether or not just everyone moved into the future an equal amount of time, and the leaders are still much further ahead of us.
I think these kinds of things tend to behave according to power laws, so that the most advanced parts advance even faster than the least advanced parts. So it's probably become actually less equal, but at
Mm.
least at least um, I don't know. Everyone is progressing. Yes, like if you imagine someone like OpenAI or whoever it is, eventually, maybe Google already, who knows, suddenly achieving superhuman intelligence, then it doesn't matter how good the monitoring and testing pipeline of some company is. Like suddenly everything changes for everyone at once, and distribution becomes completely, um, how should I call
Step
this?
function.
A step function, yeah.
Yeah. Yeah, I guess let's say putting aside maybe speculation about the things that we don't know. What would you say, like the companies that are leading the pack? Where are they from like an ML and MLOps perspective that the companies that are not leading the pack still need to catch up to?
Uh, hmm. So that's a very good question. I can I think the one I thought most deeply about. So I'm putting aside like pure research groups like DeepMind, OpenAI. They have their own thing going. It's, I think, largely irrelevant for like industry teams. It's
Interesting.
like you bash together particles in a particle accelerator. Maybe in the future it's going to enable you to build GPS satellites, but it's so far removed from um, industry teams that you need to wait like years. So anyway, they have their own methodology and their own tooling, and if I had to guess, probably a less structured process than what most industry teams have. If I focus only on industry teams, um, no matter what I answer, I'm going to make some people angry because I don't know everything, and probably I'm going to give an example of a few companies I think are doing things really impressively, and then one of their competitors or a different company will say, "Wait, why didn't he say I do things the best?" So forgive me. I only will say things that I have heard of, but I'm very impressed with at least what Tesla advertises that it's doing in its internal ML tooling. So in most companies, what we see is that people have data, usually, not huge data, which is okay. Like you don't actually need like for most applications zettabytes of data to get a valuable model. Um, so most people have like a amount of data that could fit in a large computer, and they can train a model on it for like tops a few hours and get something working, and then um, deploy it and iterate on that process. And that's like a basic workflow. It works and it's great. And you kind of maybe semi-manually think about possible improvements to the data, to the model, and you try it and you see what happens. But what I see, for example, in Tesla is, first of all, they go down to it's not really widely applicable, I guess, because it's their own specific domain, but the way they go down to the level of, we're going to develop a custom camera from scratch because cameras are designed for RGB that humans can see, and it takes too many milliseconds to process the raw photons into that. So we're going to directly feed photon detections into the machine learning model. That's crazy. Second of all, um, the and this is an idea I had like in I think 2016 when I first heard about, or not first heard, but when I first really studied in-depth neural networks. And I came to the lecture and said, listen, why don't we have like an NPM for or PEEP for neural networks where I can uh, install a module which only takes images and encodes them into a vector, and another model which only takes like a list of those vectors and combines them over time, and kind of combine it in a composable way to build a bigger system, and manage versions of these different parts of the neural network pipeline in a package manager. I chose the wrong audience. The lecturer obviously doesn't care about any of that. So he was like, yeah, that sounds cool. Good luck with that. Um, we have incorporated something very similar to that into DagsHub. But anyway, not a lot of places that I know of actually do this. Tesla is one of those places, and I think it's it. I like how practical they are in that, like if you go to researchers, academic researchers, they will say about this solution, no, that's suboptimal. You need to train the network end to end, and you get higher performance by such and such fractions of a percent, and I can prove it and submit a paper to CVPR. That's nice, but if you want to actually build a system that works, then yes, you give up efficiencies to actually make a system that you can scale out, distribute into separate teams, compose, test each part separately. Globally, it's much more optimal to not optimize everything that much. So they do that. Obviously, the whole, so I don't go too much, but they build their own data center chips and servers, which is crazy, and part of what I think is coming and going to make a difference in deep learning. And maybe the most impressive part is closing the active learning loop, like automatically detecting, let's say, sudden stops of cars in production, and using that as saying, okay, if the car had a sudden stop that the driver had to intervene, that it means that our self-driving model made some mistakes. So we can automatically, even without knowing what the mistake is, we can automatically know that this area of the recording of data is important. So we can focus on that, look at it, label it more carefully with human labelers, label it automatically more carefully with heavy duty models that can't actually run on the car because it's too expensive. And they reconstruct 3D scene from it, do super resolution on it. It's pretty crazy. Like, go look at Tesla AI Day presentations, and I think that's really few years in the future compared to what the rest of the industry is doing. Obviously, Google probably has internally all kinds of processes like that, which I am not aware of because they're more, I guess, secretive about it. I do know that they have a lot of processes internally for how data scientists document their work and how they deploy it, and basically, I think every tool and workflow automation that you can dream of, they probably have in there.
Something you're able to do when you have 70,000 DevOps people working on
Yeah.
machine learning.
And I think that's fine because, okay, you have a long tail of lots of tasks to do with machine learning. So it makes sense to have a lot of companies, and it also makes sense for those companies to do things, like I said, not try to optimize everything instantly, but like do the things that work now in a way that is simple to you and figure out where the bottlenecks are and optimize those over time. So not everyone needs to be Tesla out of the gate.
So, okay, so that covers one side of the spectrum, which you could say is like the leaders. But we've spoken over the years with a ton of different companies, and not all of them are necessarily leading the pack, and that's okay. Again, it's not evenly distributed. What do you think are the things that sort of most companies struggle with, or companies most often struggle with when it comes to getting their models to production?
Um, yeah, so that's a good question. There are several different things I can think about. There are the usual things like politics and inter-team dependencies and handoffs, especially maybe challenging when the data science team or person needs to integrate with the existing, let's say, normal software engineering organization. Um, but if I had to pick just one, it seems to me like the sheer variety and un, um, unclear differentiation and messaging of the various tools in MLOps is very confusing to people. It's very similar to Node, the Node ecosystem, where there are a lot of jokes about the Node framework du jour. Every day, a completely new, incompatible with everything else framework pops up that promises to solve everything. And eventually, what happens is so what happened, I think, in Node is what I expect will happen in MLOps, which is consolidation. Eventually, like people get tired of all the different frameworks, and everyone converges to just React with Redux and maybe some web framework, which is more varied. But and it's not that the other ones stop existing or even stop being developed or are not good. It's just that it becomes too much of a hassle to track everything and catalog everything. So I think that's where we're at now, where we talked to a lot of people who are like, okay, yeah, like I know the math of what I'm doing. I know my data. I kind of know what I want it to do in production, but like, how do I get from here to there? Does SageMaker solve it for me? And like, and usually the question is framed in a way of, does tool X do this for me, and or does tool X do DevOps for me, MLOps for me?
Mhm.
Sorry. And the answer is no. Just like there is no tool X that does DevOps for you, it's like a collection of tools that need to work well together. So um, some if I take the analog from DevOps, maybe it will make it clear. So if someone says to me, does Google Cloud solve DevOps for me? Like technically the answer could be yes, if you use a bunch of different stuff that exist inside Google Cloud, you could do it end to end. Like you could use Google Cloud's Git repos, and you could use Google Cloud's build system, and you could use Google Cloud's monitoring, Google Cloud's Kubernetes. Usually you don't want to. Like, why would you use Google Cloud's Git repos and not GitHub or GitLab or DagsHub or any of the other much better ones?
Mhm.
The problem is that, that it's still pretty hard to separate the marketing messages because not everyone, but a lot of vendors say they do everything. and people just want to be told an answer, and because they don't come at it in my opinion, because they don't come at it from first principles, then they just want an answer that lets them check the box of I chose a tool that will do MLOps for me, where in fact the best thing to do would be to stop and say, okay, what are you trying to do concretely? Do it by hand a couple of times, and then see for each part how you might do that better. It's still hard because like the terminology is kind of conflicting still, like what exactly is orchestration, what exactly is I don't know, monitoring, or let's see, what example did I have very recently? Something with data. I don't know if it's exactly this example I had in mind, but sometimes people would say, I need to do machine learning. I need the data lake or something like that. I'm like, what do you mean you need the data lake? What do you need? And so like, I need something like Delta Lake, okay, specifically, let's say, which is a specific open source / commercial offering from Databricks. And I said like, okay, why do you need Delta Lake? Because we heard it's a part of the ecosystem, like MLOps ecosystem. I'm like, okay, what's your data? And I say, we have images and videos and some tabular data and some other stuff. And I say like, okay, you know Delta Lake only offers tabular data, right? And it's like more relevant for actually like BI use cases where you want a data warehouse. And yeah, just getting to know all of those terminologies and what actually they're useful for is very challenging. Yeah. And a lot of people just choose stuff that is not actually what they need. Or sometimes I see people like using Spark from day one to process their data and stuff. And like, okay, how much data do you have? I have 5 gigabytes of data. Okay, why are you using Spark? Load it into a laptop, load it into memory. like,
Yeah.
So those are the kind of issues I see.
Yeah, there's a mix-up between terminologies, buzzwords, and problems. And if you sort of convince yourself that a buzzword or a term will be a solution to a problem, then it's sort of a mental shortcut. Like you don't need to think about the problem any longer because you know the class of solution you need, and now it's just the easier problem of choosing which one of the tools that sort of covers this solution is the one you want to choose. And I think that the manual part is just it's very hard because it's more mentally and technically taxing for people because they actually need to solve things. I think that from our experience, once you actually go through with it, the realization you have is many times a well-defined problem that doesn't easily fall into any sort of clear buzzword. And that's when you're sort of now really moving the needle for your sort of ML platform or MLOps solution or whatever you want to call it, because you're actually dealing with hard realities of your specific use case. So I think that that's really critical. We have sort of we give a talk about solving MLOps from first principles and how to think about these things. I think that's really critical. And the failure mode that you described with like, I have a problem, so this is the feature or this is the sort of buzzword term that I'm looking for. That's something that is a recurring theme, and it's okay. It's part of the I don't know, discovery life cycle for many companies that are getting into the field. But sort of I think the message that we like to impart when it seems like people are listening is that trying to figure it out in a hands-on way, like really understanding um, w- what your specifics are and how you can solve for those. That is sort of the right way to go if you
Mhm.
can do it.
Yeah, I
Yeah.
can accept that. Maybe like big enterprises have to kind of try to do central planning to solve these issues and choose some tool that will be at least they can uh, make a case that they thought it would be future proof for the whole
Yeah.
organization. I think I like in my experience, not in the mail, in other stuff, I think it usually is like failure, but yeah, big organizations have their own problems that are not technical,
Yeah.
and
Yeah. That's
no one's fault. It's just a sad reality.
yeah. Yeah. I don't know. Like, it's very hard to take those things into considerations from both sides, I guess, because I'm not sure these larger organizations are always aware that's what they're doing, and I'm also not really sure whether or not some MLOps, some tools, not necessarily MLOps, but in general, like some tools try to cater to those at the expense of not actually solving the problem, and so setting everyone up for failure in the long
Mhm.
term. Again, not because of malicious intent, but because of sort of the I don't know the failure modes and
Yeah,
the misaligned
I,
incentives in how to do these things.
I have my own belief, which is I think somewhat backed up by recent experience of the last couple of years, that um, machine learning is progressing so fast that it is kind of irrational to expect to have a tool that does everything for you, or like even uh, yeah, like a single vendor that will be able to solve everything for you in a way that you will be happy with in 2 years.
Yeah,
um, yeah, so it's, to me, should be understood that it's a research area. Research areas change. You should not attempt to optimize them to the last drop, because then you will just pay even more in the long term, much more than if you kept things agile. Um, of course, it depends what kind of machine learning you're doing. If you're doing like basically traditional BI, except you're adding a linear regression model on top of it to uh, project stuff into the future, then okay, sure. Like there is a very good ecosystem around BIs and data warehouses that you can be pretty sure is not going to change that much. Um, just be aware that that's what you're doing, and don't try to enforce the same tools on your highly experimental self-driving research team or something.
that's uh, that's a good point. So I guess in the spirit of mental models or ways to think about these problems, there's obviously a lot of similarities, but also a lot of differences between the things that we as a community, as a field, have learned in the worlds of classic software development and DevOps, and then machine learning and MLOps. So first, I guess the first part of this question would be like, where do you think that you can very easily analogize between one field and the other? Where do you think that analogy breaks down and you need to sort of tread carefully to not overfit? And and yeah, and like, what do you think are tips that were already learned in blood and in the world of classic software development, and haven't yet maybe percolated into the world of machine learning, but should?
Um, so I already we already talked about how I think in recent years uh, people have matured out of the notebook flame wars, like,
Yeah.
which is maybe the first part where um, so if you're a data scientist that comes in with an attitude of I'm a scientific researcher, I am doing proofs of concept, I don't need to learn about any tooling, I don't need to version my code reviews are for people who write CSS for a living, that's boring. We have talked to people like that a couple of years
Yeah.
ago. I think that would have been then my answer to things learned in software which were written in blood, which is use version control. And I think that has kind of already been absorbed. Let's see now. So here I'm a bit more hesitant. So obviously version control, I think due to technical reasons, sadly, the existing ecosystem for version controls and diffing for code does not work well for data unless you add things like DVC or other tools, which is what we do at DagsHub. But honestly, it's less convenient. If Git would have been, I don't want to say better design because I'm afraid of Linus Torvalds, but would have been designed for also handling large files. It's not impossible. It just wasn't done. Then you could have saved everyone a lot of hassle. Or even,
Yeah.
or you say, okay, my data is too big to even fit anywhere near, a local copy of a Git repo. Okay, so let's have a standardized way of also extending that versioning to cloud stored data. It's again like not trivial, but obviously doable. The parts where I guess one gap which I still see is the whole idea of continuous integration, continuous deployment. Some companies do actually use it for their ML teams, especially the ones that are more like engineering oriented and less, I guess, research oriented, where like there should be no reason ever to kind of manually, except for the initial proof of concept, okay, to have a manual process for deploying stuff. You do it once manually, then you write it in a script, and ideally you trigger that script automatically based on events from source control, like pushing to the main branch. You might call it GitOps. I think there is no, like, even if your data is outside of Git, your models are outside of Git, that's all fine. Still, you want, at some point, there is metadata which is small enough to fit into Git, and you want that versioned and carefully automated in its deployment so that you can roll back if there's a problem and everything.
I would also
So,
add to
yeah.
that, or maybe add some detail. I think that the actual process that should work is you manually deploy once, you make a ton of mistakes while doing it because it's the first time. You manually deploy a second time after you cleaned out all the stuff you did, which are sort of useless or mistakes that you fixed along the way. And then sometimes, in certain cases, it actually makes sense to write sort of pseudocode or like a pseudo process for the deployment and let someone else try it just to make sure that it's not only working on your machine. And then you should automate that properly. I think that that's something that we've done internally at DagsHub when we've had more complicated processes that relate to deploying machine learning models and things like that. And I've also seen this in other companies that we've spoken with that have sort of approached this in a way that makes more sense to me. So like you don't necessarily want to automate it straight after the first time you deployed it. You might want to fix the things that you.
I mean, after the
sort
first
of.
time, you consider it successfully deployed.
Yeah, fair enough. Fair enough. But it's an important caveat. Like you don't have to succeed in
Yeah.
automating everything on the first time,
So,
literally.
yeah, yeah. So, I guess remind me if I forget it about TDD before I talk about TDD, I want to talk about what I see is different in machine learning versus software, because not everything is the same. So you, first of all, you can't expect to run a machine learning CI/CD pipeline, let's call it, on every commit, every push to the branch, like you would in software, where you just run some unit tests, some linters. Maybe it takes 10 minutes if it's long. Because training a model takes like hours, maybe, and it's very expensive. So there are all kinds of best practices that you do not want to do, like software best practices that you don't want to take over directly. You do want, let's say, maybe to have a workflow that says I do training on a small subset of the data automatically. I do a sanity check there, and then I wait for like a trigger from a team member that reviews the submission before it's run on the full cluster, and only then it can be merged after running the full training on the full cluster, for example. And just the sheer amount of iterations and experiments, because in software, and this maybe relates a bit to TDD, which I'll talk about in a second, there's not really a concept of experimentation unless you're specifically benchmarking, like trying to tune some performance. You write the code, it works or it doesn't work. The amount of iterations is relatively limited. Versus in machine learning, where I just want to train the model a bunch of times with different hyperparameters and different random seeds and see what happens. So, for example, if you... Sorry?
Yeah, I'll mark that.
Cut that part out. Okay.
Yeah. Wait.
So, for example, it might seem like it makes sense to git commit every single experiment, but obviously, if you have hundreds of thousands of them, then it's not that it's not possible. Git will handle it just fine, but all of the existing user experience around it will not like that at all. So you want to be more selective. And just, the scale of data itself, which sometimes, for example, doesn't allow for wasteful things that you might want to do with code, like copying it and modifying one line and copying the whole data set sucks. So you have to be more careful with how you organize your data. So about TDD.
About TDD.
Yeah. So it also relates to TDD for me, because TDD is kind of an attempt to bring the experimentation, fast iteration workflow to software. And I think it's super valuable, and data scientists don't do it enough. Software developers don't do it enough.
Yeah, start with what is TDD for if
Yeah. So I'm not some guru or anything about it. I just have done it and found it extremely valuable for me. It's about, let's say you're writing some function. You want to first write like the signature of the function. You know what it needs to do, more or less. Then before you write anything in its body, you write a unit test that calls the function with some expected input, verifies its output, and now it branches off. The purists will say, first you write all of your test cases, you verify every single possible input and output, and you verify that they all fail. This is important. First verify that it fails, because maybe it doesn't even check anything. Sometimes you have bugs in your test. And only after everything fails, then implement the stupidest possible body for the function, and then see that everything is green, everything passes, and that's it. Don't touch the function anymore, or refactor it and make sure that after each refactor the tests all still pass. That's the purest way of doing it. I
And to add, because I
think
don't
that,
think we said
yeah,
it, sorry, the TDD is short for test driven design. So I'm not sure if we said
yeah,
that anywhere. So yeah,
test-driven development.
development,
Uh,
sorry, not design. Yeah.
yeah, I think there's also like DDD, which is design-driven development or something, but I honestly don't even remember what it means. Um, so yeah, that's the purest way of doing it. Um, I'm not a purist. I like writing at least some of the test cases in advance, but even if I just write one, which doesn't even test anything interesting, what it does give me is a way to quickly invoke, like usually you write a function, it requires some kind of context, maybe it's a method on an object, maybe it requires a bunch of complicated parameters. So when you write the test, you give yourself a way to um, invoke that function in isolation without having to run the whole, in case of software development, the whole server, and going through the screens to get to that specific location. And each time you test what you do, it takes a long time and you just don't do it. So that's what you don't want to do in machine learning. Maybe what you don't want to do is to have to rerun the whole notebook from start to finish every time you want to, like, you realize you had some small bug in a cell. Um, so yeah, write a function, write a test, a unit test, which again, the unit test can be just like a function. It doesn't need to be anything special. If it's a notebook, maybe it's just a notebook cell that activates the function in a configuration. But once you have that, then you can step into it with a debugger very easily, and you can just develop much faster. And also, if you find yourself not being able to write the unit test because, for example, the function is using global variables and it calls all kinds of functions that, I don't know, access a database that costs $1,000 per access or something, then that means you have written your code badly and you should change it so that all of those things are well contained and can be replaced with mock versions. So it makes you write better code. It gives you much faster iteration speed when you test. Like, okay, I think I wrote the code correctly. I'm going to test it. Okay, it didn't work correctly. I'm going to step into it with a debugger really fast, fix it, test it again. It just makes you develop much, much faster. And I think in machine learning, they haven't. So again, in software, I think people don't do it enough, but in machine learning, especially not. Partially because a lot of people just don't even bother writing functions and thinking about stuff like encapsulating external, like, global variables and stuff, and making sure you don't that the function is kind of consistent and doesn't depend on global variables. So they don't do that. And even if they do, I'll give a concrete example. So I think everyone has had at some point the experience of trying to write neural network architecture in PyTorch or something, and you run it, and it looks fine. Like, after you get over the quick to debug stuff, like the shapes of the tensors that you thought you reshaped correctly in your forward function, the shapes are not correct. Okay, you fix that. That's easy to fix. Then you run the training loop, and you see, okay, the loss is going down, but the accuracy is not improving. Let's give it more time. Okay, it's still not improving. Okay, let's give it more time. And then, like, good luck figuring out where in your giant forward function you did not actually, like, let's say you calculated the loss not on what you actually should have, or you didn't back propagate gradients to what you should have. So the network is reducing its loss, but it's not actually learning anything. Happened to everyone, I think, at some point. It wastes a ton of time. Instead,
Yeah.
if you had just tested this thing first, like every step along the way, you could have saved yourself a ton of time and possibly money if you actually went and tried to run this on like a GPU cluster or something. Also, of course, about data transformations, trying to test them one step at a time. And yeah, things like assertions on, okay, I expect this column not to have missing values and stuff. So you have frameworks for that, like Great Expectations, like deep checks, which can do these assertions for you and let you avoid a bunch of hassle.
Yeah, but I think that the point
Yep.
you're making. So first, we'll add some links in the description for things that people can read if they want to better understand test-driven development and maybe ways to apply it to machine learning. I think that even in the case of things like Great Expectations and deep checks, where you have someone who developed a dedicated system for data science, they it would still be healthy to start thinking about things from a test driven perspective in order to know what you're doing there. Because I think a lot of times, it's like, oh, we solved data validation. We just run this framework and we do like data dot
Yeah.
validate or something like that. And that's not good enough if you don't know what you expect to see. Like it's called great expectations because you need to set expectations first and then you can automate checking them. And I think that that's really important. So you should probably read a bit about this, especially if you're not already implementing it. And so we'll add some links. I guess to finish off before we do recommendations, what do you think is the most exciting topic in machine learning right now, or in MLOps right now, and why?
Um, yeah, that's hard to say. I'm putting aside all of the, I guess, more researchy AGI stuff that's going on. Or maybe I should briefly. I
For
think
machine learning, it still works, not for MLOps maybe, but yeah.
you know what? I'll state it briefly. I think if you look objectively at the expected acceleration rate versus the actual acceleration rate we've seen in the past few years of deep learning, that if you look at it objectively and you don't have like a bias, then you have to conclude that things are progressing much faster than we thought. And there is actually no good reason to think it's going to significantly stop. Like, yes, there are going to be probably a bunch of S curves that we come to a plateau on some method, and then we need a theoretical breakthrough to achieve the next thing. But it's already happened, like I think 3-4 times since since the ImageNet moment, and it's going to happen more. So anyway, I think we are looking at some superhuman AI being a proof of concept at least this decade, or maybe the decade after that. Again, as a proof of
Makes
concept,
sense. Yeah.
as a proof of concept, I think, and again, it's not going to be superhuman maybe on every dimension. It's not going to be a good massage therapist probably that soon. Um, but maybe the thing I'm going to say there is that I think it's going to be a proof of concept, and then some people are still going to be, yes, but where is my robot butler? This is all like bullshit. It's not actually a breakthrough. It's not actually happening, because between the proof of concept and actually achieving stuff in the physical world or even in industry, there's a lot of engineering to be done, not
Mm-hmm.
like scientific breakthroughs, like closing the data loop, as I said with what Tesla is doing, like better robot designs, better internet. I don't know. It's going to take probably another I don't know, decade after that before it actually uh, is shockingly effective at, things that people really experience. And in that time frame, there's going to be a lot of, you see, we told you it's all made up. Um, so that's kind of my opinion with,
It
I
would be
guess.
interesting if we get AGI and sort of the last barrier to real superhuman intelligence in sort of in machines or computers is MLOps. Like we have it and it's working in theory, but now we need to deploy it, and that's sort of a whole other thing that we didn't spend time thinking about because we were so
Then,
busy with, yeah.
then you're a physicist, isn't it? Isn't it exactly what's going on with fusion and quantum computing and quantum encryption?
There's, I mean, there is something to it. I think that those, so fusion is a bit different because I think it, as far as I understand, didn't get the amount of resources it should have got to get to a point where it's actually applicable. So it's not necessarily as much a technological problem as it is an investment problem, which is now changing. So maybe it's going to be different. With quantum, it's a different story because I think that one of the challenges was like was and still is that it works it works like in a lab, but then how that should affect real humans is not a well answered question. Like there are startups working on this, but similar to other fields, and I don't want to step on anyone's toes. I think, like, I mean, I did quantum research. I think there are a lot of other interesting fields, but there wasn't a sort of a necessarily a killer app that we started with, and we're now trying to solve for. With AGI, like every child can imagine something which, if you had sort of um,
Mm.
putting aside the ethical issues, right? But if you had a machine which was as smart and as capable as a human being for everything, like what you could do with that, I think that's very easy for people to answer. So so I'm not sure it's exactly the same. Like I understand what you're saying. There are
Yeah.
some aspects of this analogy, but yeah, but there are differences as well.
So, so fusion is maybe so. Yeah, everything you said, I agree. I guess quantum computing has effects on mm, re, like research, right?
Yeah,
Materials,
I mean no, I mean if
biology.
you had large scale quantum computing, then you have
Like
all
you could
the whole
simulate.
like yeah, and we can break all of the encryptions that the world is using and stuff like that, which is very,
Yeah, but that's
let's say, nefarious. But it's not an application. And I mean, it's a malicious application maybe, but it's not something that improves people's lives directly. It maybe makes them
it's
worse.
also
Uh,
I think it's like the commercial use case immediately, but it's not actually interesting because we could
yeah,
make quantum resistant encryption. It's just not
yeah,
ROI positive right now because there are no quantum computers yet.
yeah. It's not. It's we're not yet at the arms race phase for that. For
But
good or for
like
bad.
simulating physics is highly relevant for like uh, understanding biology better, drug discovery, material
Yeah.
sciences. It's harder to predict what it's going to do. I agree. Than at least
Yeah, I mean,
near
yeah,
term AI.
that's also equivalent to, for example, what DeepMind achieved with AlphaFold, and I mean,
Hmm.
it's already a breakthrough. It's already making some impact on our lives, but it's still, I think, further into the future where it's very clear to every person on the earth how this has affected their lives in the same way that the internet or computers or something like that has already affected us. Um, but yeah, but that's.
Hmm.
I mean, I just I feel like it's fun to talk about this, but I haven't really thought about that
Uh,
as sort of an interesting point of like, yeah, we get AGI, it's just not functional at all because we haven't properly solved MLOps, so you can't really deploy it anywhere. That's
like
interesting.
realistically thinking, it's going to probably be deployed very fast in one place, which is the stock market, and
Yeah,
who knows
maybe. Yeah.
what that's going to do. Um,
Maybe
But
the
yeah, in
stock
terms of
market is fundamentally unpredictable unless you deploy the AGI to something that can affect people's decisions, in which case you still need a better deployment mechanism.
that, no, it affects buying and selling on the stock market affects people's decisions.
You mean like a feedback loop? Yeah, yeah, that's fair.
Game
Um,
theory.
okay, so yeah,
Anyway,
sorry.
like putting aside the theoretical stuff, in terms of like more concrete MLOps, there's the whole thing I described with like closing the active learning loop, which I think is in its infancy right now,
Mhm.
directly tying back production into training, fine tuning in a systematic way, hard example mining, simulation, maybe even simulation is something which I think doesn't get enough attention, um, but probably is going to get much better. And also stuff like more complex deployment patterns, like for models like shadow models, canary deployments, which there are tools for that, like Seldon
Mhm.
does at least some of that, but it's not like well adopted yet.
Adopted.
And
Yeah.
for me, at least, like I'm also excited by JAX and better chip design for deep learning, because it's kind of ridiculous that we're still using GPUs for neural nets when we know, like, it's not even theoretical, like that there are much more fitting architectures for neural networks.
Yeah.
You have 10 TPUs from Google, which are kind of no-brainers, but the existing tooling doesn't support them that well yet. Not to mention stuff like Habana, which is like Israeli startup, which I don't remember exactly the use case, but they also like do more neural network optimized chips. It's just generating
For inference.
hardware and drivers takes much longer than people like think.
Yeah.
We even struggle to manufacture GPUs when geopolitics doesn't allow it.
Yeah.
Um, so I think there's a ton of value still left over there, and Jax hopefully is going to make it much faster to adopt.
Yeah, awesome. So that's I think it's a good note to get into the final section, which is recommendations for the audience, and it doesn't have to be data science related. So anything you're reading, watching, listening to that people should also try out.
Um, so I always recommend the blog Slate Star Codex or Astral Codex 10 by Scott Alexander. Um, I learn a lot from it. I really like how so it covers a lot of topics, but especially relevant if you're interested in AI, rationality, um, but basically every topic under the sun. And it's a good place to get information. Like they, he really tries to be objective and get all of the information about the topic. On that note, I also recommend companion blog called I guess it's called "Don't Worry About the Vase" or something. It's by a person called Zvi Moshowitz. Why do I recommend it? Because he has been the most informative, like in hindsight, correct and up-to-date source on everything related to plagues, COVID, monkeypox. Everyone who asks me, wait, what do you think about COVID? What's going to happen? Monkeypox, blah, blah, blah. I just say, here, read this blog. He summarizes it in the first paragraphs, what you should worry about, what you shouldn't worry about. If he's not worried, I'm not worried. If he is worried, I am worried. So I recommend that. And also there's a podcast for at least Star Codex. Um, ah, I watched. I don't watch a lot of TV shows. Me and my wife don't have enough time, but I was a reader of Sandman, the comics,
Mm.
once upon a time, and I was kind of worried about the TV show that came recently. Like they turned it into a TV show, The Sandman, obviously on Netflix. I was worried, but they did a excellent job It's like almost one-to-one faithful to the originals, and I think it was very good. So I would recommend that.
Okay, awesome. I don't have any special recommendations for today. So with that, Guy, thanks for joining. Yeah, you want to add anything before you finish off?
Yeah, I forgot. One more recommendation, a band. Lady Silver. Search for it on YouTube. It's a Friends band. They're very good. Somewhat Arctic Monkeys vibes, if you know them. Check it out.
Awesome. Well, on that note, thank you for taking the time to join the podcast today. It's always great to chat. Now everyone gets to hear us chatting. So yeah, have a great rest of the day, and bye everyone. Thank you for tuning in. See you next time.
Thanks. Bye-bye.
Bye. Thank you for listening to the MLOps podcast. If you enjoyed this episode, please like the video or subscribe. If you have any feedback, leave a comment below. Thanks again for listening, and see you next time.